Hello everyone, I hope you all are doing great. So let's move on to today's daily challenge on Leetcode. So there are multiple ways to solve this, starting from O of n log n to then O of n also. But these methods won't work because it's like the constraint of n is close to 1e9. And I have already shown these methods in my previous video. Link is in the description. You can just go and check that out for getting some idea of how to generate lexicographical order of given numbers from 1 to n. But I will show you today's method, which is O of log n square. Okay, so how that's coming in detail we will explain using prefix tree. So stay till the end of the video and definitely subscribe to my channel. If you like it, it gives me more motivation to make such videos. So yeah, we need to find the kth smallest number in lexicographical order. And unlike the last problem, we do not need to return all the numbers in the range 1 to n. And because because kn anything may be of the order 1e9, so you need to return the kth lexicographical smallest integer. So let's say you have this n equals to 13. All the numbers are written here, and the second number we are asked k equal to 2, so that's 10. Okay. So yeah, let's move on to the solution of how it will work. So you see, I have already told you in the previous video about some intuition regarding if we want to write something from O to n, let's say n is a very large number, then we will go on with something like this. First there will be 1, then there will be 10, then there will be 100, then there will be 1000. And how things unfold, we have all seen. Okay, when we are storing n numbers in a vector, how exactly the things will unfold, we have already seen it, right? And then the last number will go on like 1001, 1002, all the way till 1009. And then what we will get is 101, and then it will be 1010. Okay, so I have already explained you all these things, how it is coming in the lexicographical order in the last video. But here you need to find the kth number. You find the kth number in, and you are not allowed to traverse. Okay. But now, if you know of prefix tree, what you can do is that you can try to think something like, if I can group every number which is starting from 1, which is starting with 1 in some category, and I can group all the numbers starting with 2 in some other category, similarly till 9, I will do it. And then again, I will group some numbers which starts with 1 and the second digit is 1, which starts with 1 and the second digit is, let's say, 0 or something like that. So I can group that number, then we can form some tree. And if we traverse a tree, we know that the height of a tree is of the order of log n, right? The height of a tree is of the order of log n, and if we try to traverse the tree, then there might be some possible approach, right? So this is the intuition which works and which you need to perform in order to come up with the idea that yes, we need to perform some prefix tree calculations here. Okay, so let's try to see exactly how that prefix tree approach is going to work. Let's say, as I told you, I am going to group all the numbers which starts with 1. So 10 will be under it, let's say. Then you will also have 11. You will also have 12. And all the way till 19, you will have this under this one. Okay. Under this one, you will be having this. Now, if you check, under this 10, I will say that all the numbers which starts with 10. Okay. So 100 will be there. That starts with 10. 101 will be there. All the way till 109 will be there. All of these starts with 10. Okay. You got this. I think you got this. Now, again, there will be 1000 is there. And all the way till 1009. Okay. You are trying to group the numbers this way. And you get now 2. You do something similar. You try to find 20 here. You try to find 21 all the way till 29. And you will do something similar. You go to 200 all the way till 209. And you can go on like this. Okay. For 3, you will get something. For 4, you will get something. And in this order. So you do get that. And let's say it also has a root. Let's say, the root has no name. Let's say just nothing. Okay. Okay. So let's see, you want to stand on the kth value, right? And by iterating the graph, you can reduce the time complexity. You need to stand on the kth value. So you keep a pointer current pointer. It will go through, initially it has the value 1. Okay. It will go through all the values, and whenever it will take one step, the value of k will be decreased. Okay. And when the value of k will be 0, then we have reached our answer curve, and we will just return answer. Okay. So this is the very basic intuition which is there. But how exactly are you going to count the nodes in some constant amount of time or log n amount of time, right? So what you need to do is that you need to have some observation. First of all, in this prefix tree, you need to have some observation. What is those observation? When you have a number n, if you add 1 to that number, you do n plus 1, then you move to the right of the tree. Okay. Let's say you are having 11, you add 1, you just move to the right child. When you are having 2, you add 1, you move to the right child. Okay. So when you are having n and you go to n plus 1, you move to the right child. Okay. This is now observation. This is one observation. Second observation is that when you multiply a number by 10, when you are multiplying a number by 10, you are moving one depth ahead, right? So when you do n into 10n, you are moving one depth ahead. You see, when you do 1 into 10, you move one depth. 10 into 100, you move one depth. 2 into 10, you just do it. You move one depth, right? So you are moving one depth here. You're moving to the child, and in this one you are moving to the right sibling, right node. Okay, so now as you are having some intuition that what happens when n goes from n plus 1, n to n plus 1 and 10n. So let's just see, what if the value of k is something like 220. Okay, so it is not in any of these node, right? So what I can do, I will write a function, I will write a count function which will count the number of steps it needs to reach from 1 to 2. Okay, so I am currently on 1. So first of all, my current pointer, I will do it 1. Okay. Since I am already in 1, I will do k minus minus, because I have already taken one step and I am standing on 1, right? This is my first number. Okay. So after this, let's say we get a variable cnt which counts the number of steps it is required to reach from 1 to 2, given k is 220. I mean the value of k you need to reach, whichever it is, it's 220, right? That's k's. Now k here denotes the number of steps we need to take right now. Okay, we need to take. So you see what you do, whenever you see this k value is greater than my current value, so I need to take some steps. So what I will do, I will just pass the function between cur and cur plus 1. Okay, I need to count the steps between cur and cur plus 1. So it means that if I am in 1, I will count how many steps I need to take from 1 to get from 1 to 2. Okay, and if you see how somehow you see now, and you understand, in log n time I will get this function which will tell me what is the count of the number of nodes from 1 to 2. Then once we have reached this, we will subtract this from k. Okay, we will subtract this value from k. So now we need to take k number. K is the number of steps remaining. Okay, this is the number of steps which are remaining. Now I am standing on 2. Now I have from 1 to 2, I have taken some steps, and now I am standing on 2. Now I need to check how many steps I will take from going from 2 to 3. So how exactly all this is happening? You just have patience and look in the code. I will just explain you in great detail. So as I told you that I will be having initially some cur integer, right? Some cur integer which will be initialized to 1, and still I am already standing on 1. It says that on which node I am standing on. It says on which node I am standing on. Okay. Now while k is greater than 0, I will do a loop. I will do a loop while k is greater than 0. Okay. As k becomes exactly 0, whenever k becomes exactly 0, I will just break out from the loop and return curl, because this is the element which I'm currently standing on, right? So if I have, let's say I want to take first step, I have already taken the first step, I am standing on the first element, right? So that in that way, okay. So now what I do, I returns this count, which will, I write a function count steps, which takes count steps from cur to cur plus 1. Okay, I just write this. Now what you need to do is that you check that if this count value is something, I mean, when you need to move to the next step, if this k is count is still less than equal to k, it means that I need to take more steps. I still need to take more steps. So I will just do cur plus plus, and I will subtract this count value from the k. Otherwise, what I will do, it means that I have taken more steps. The remaining number of steps is very less. So this means that, first of all, this means that I have taken less steps than remaining steps. So that's why I move to the right child. That's why I move to right child. Okay. And decrement remaining number of steps. Decrement remaining number of steps. Okay. Now what I need to do is that in this case, I have taken more steps than remaining steps. So don't perform it. Don't perform it when we are exactly performing it, when we are subtracting this count from k. So we will not subtract this. So don't perform it. Instead, what you do, go one level deeper. Okay. What you need to do is that you simply just go one level deeper. Go one level deeper. Okay. Now you have moved one level deeper. And in this way, you just go on. And now, how will you write this count steps function? You write something like count steps. Okay. And this has an integer n. Now this current might be an addition, right? So I just define some hash, define long, and this, let's say this is some prefix 1 and prefix 2. Between, what this, it does find number of steps to go from P1 to P2. Okay, how many number of steps I need to go from P1 to P2? What I do here, while P is something like less than equal to n, I just keep going one level deeper. I just go one level deeper of both P1 and P2. I'm just explaining this to you, how exactly what does this work. So I'm going one level deeper and I am adding something to my answer. I have my steps answer as 0. I am doing step plus equals to P2 minus P1. Okay, so let me see how exactly does this step works. Return just the steps, right? Okay. So how exactly is this working? If you try to check, how exactly will this work? How exactly will this count function work? Okay. So you see, number of steps you need to take from 1 to 2. Okay. And let's say you have something like 21. So how I'm not 21, yeah, 21. You just take it for 21. So what you do, you initialize P1 as 1, P2 as 2. Okay. Now you do just answer plus equal to P1 minus P2. P2 minus P1, right? So your answer is now 1. Your answer was initially 0. It is now 1. Okay. Now what you do, you just do this P2 minus P1. P2 is, you just increment this P2 into P1 equal to 10. So now P1 goes here. And same you do for P2. P2 goes here in this. Now you subtract again P1 from P2. You will get the number of nodes here, right? You will get all the number of nodes here. So again you do answer plus equal to. This is what we are doing in the while loop, right? You do understand it, I guess. So you just add the 11 now. Okay. So you see, after exactly 11 steps, you have reached 2. And you cannot go any deeper because it will get 100, and 100 is already greater than this 21, right? 100 is much greater than this 21, the value of n. Okay, so you cannot go much deeper. So what you can do is that you see the number of the count which you return, you just return 11, and you see the count which you return. So that is less than the value of k. Let's say k is something, if we need to return 21, then k will be greater than 11. It will be something greater than 11, right? So what happens is there that this 11, this k now what is the criteria is that my count is now less than the k. So I decrement the count from k and go on one level deeper. Then I try to check between 2 and 3. Now I will see that 2 and 3 count is much greater than the remaining steps. Now count is much greater than the remaining steps. Remaining is nothing but k here. Then I will go one level deeper, 20, and perform the same thing again and again. So that's how exactly this step works. Yeah. So let's try to run it and check if it works. So we are getting some wrong answer. Let's see why exactly. Okay, so when I'm going one level deeper here, you see, I am taking one step, right? You need to decrement k. Take step. Okay, you are just taking step. When you are decrementing k, you are taking a step. This is take step means start from. Okay. So let's try to run it now. Yeah, so let's try to submit it if it works. Okay, so we are getting some wrong answer. Let's try to understand what exactly is the error in the code. Okay, so you see one thing is that this P2, I am always doing this P2, right? But what if in my case I told that I am just moving one step and adding this P1 minus P2 minus P1. But what if nums is something like n is something like 13? Then we need to stop here only, right? So 10, 11, 12, 13. These are all the number of nodes that we will need, right? So we need to stop at 13. So what we can do here, we will keep a minimum function which will take P2 or n plus 1. Okay, n plus 1 because I need to count that n value also. So what I will do here, I will just keep a minimum function which will just take n plus 1 and this P2. Yeah, let's try to submit it now. So no matching function, so P1 is long, so I guess that's why it's giving a wrong answer. Let's try to check it quickly. Submit it now. So yeah, we do have the accepted thing. We also have a 100% runtime complexity. So I know this problem is not at all intuitive. If you have not done similar stuffs about prefix tree earlier, you might not be able to generate the idea, but I have tried my best to make you understand by showing some visual stuffs as well as in the code. So if you have understood the problem, no, it's very, and it's everything is fine, you can just comment it, yo bro, in the comments, right? I will just get to see how many such aspirants are there who are preparing seriously. And if you have not understood, definitely comment the timestamp of which portion of the video was doubtful. I will definitely try to explain that again. So yeah, that was all for this problem. This was a hard problem if you are not aware with prefix tree kind of stuffs before. But yeah, that's all, and I hope your day would be much easier than the problem. So yeah, thank you so much.